Welcome. So in this video, we're going to be continuing our conversation on sig figs. In our first video, part one, we talked about how to look at a measurement and figure out which digits are significant and which digits are not significant. Now in this part two video, we're going to use that information and see how many sig figs are in our final answer. We're going to do that for addition and subtraction and multiplication and division. So let's start with addition and subtraction first. All right, so addition and subtraction follow the same set of rules. When we're looking at a problem involving addition or subtraction, we're going to be looking for where our smallest common sig fig is. We're going to be looking for the smallest sig fig that they both have in common, and then we're going to be cutting off our sig figs there. So I like to approach these problems visually. So you'll see me lining up digits, you'll see me using marks and underlines so that I know where to stop my sig figs. When it comes to addition and subtraction, I don't really worry about counting a number of sig figs. I don't find that very useful. That is a skill we'll use later for addition multiplication and division, but I don't count sig figs when it comes to adding or subtracting. All right, so let's say we got a problem like this, just written like this: 103.65 grams plus 48.3 grams. The way I like to set up this problem is very visually. So I'm going to be lining up my digits. All right, so I go 1, and I give about equal spacing for my hundreds place, my tens place, ones place, decimal point, my tenths place, my hundredths place, so on and so forth. And I'm going to stick with that same lining for the 48.3. I'm going to stick my 4 under the 0, and my 8, decimal point, and then the 3. All right. Now these types of problems are quite common where you might have some gaps like over here and or over here, and that's totally okay. We're gonna deal with that. All right. Now for the gap here, that's really not a big deal at all. When we add these two numbers, they're gonna be in the ballpark of like 150 about. And it doesn't really matter that I don't have any information here for the second measurement. That doesn't mess with like the precision or anything. Where you have to start worrying about precision or sig figs is on the smaller end of the problem. So for us, that would be here when we're thinking about like the tenths place and the hundredth place. So before we do the math, I just want you to kind of think about why sig figs matter. So here, we have, forgot my units. All right, so here we have a measurement, 103.65. That was measured more precisely than our second measurement. We have precision information in the hundredths place, whereas the second measurement does not. What this means is if we add these two together, because we don't have any sort of idea what's really here, we're going to lose our precision in the second spot. Okay, so what I like to do is I like to draw a line here, right, where that precision ends. Okay, some people like to underline. I do this sometimes. I like to underline all my significant digits. This is definitely optional. And then I'm going to do the same here. And then visually I can see that my shared common precision, the smallest spot where it still happens is the hundredths place, but afterwards I lose that shared precision. So in other words, another way to think of it is because I have a blank here, I have to draw that line there. Or another way you can think of it is because my numbers, my digits, more precisely my significant digits, ended at this spot, that's where I draw my line. Okay. This line is not a decimal point. That's our decimal point. Line is just telling me that everything to the left will still be sig figs. Everything to the right will not. Okay. That doesn't mean we don't care about this 5. We're going to still type this into our calculator or do the calculation completely as normal. Okay, type everything. So 103.65 plus 48.3 equals, and we get 150. I might have to get a new marker. 151.9, and then I'll put the 5 here. Grams. Okay, 151.95 grams. So again, do the math in your calculator as normal. Okay, the only difference is when you're considering sig figs is how you're going to round the number. So 5 and up at a Chem 101 level. This is I teach chemistry. I realize not everyone watching this may be in chemistry, but at a Chem 101 level, we just go 5 and up, rounds up. There are more advanced rounding rules involving 5s. I think for this video, we ain't gonna worry about that. All right, don't worry about it. So round up, we go 1, 5. Oh, this is fun. That's gonna round up to a 0, and then we're gonna have to carry a 1. 152.0 grams is how I would report the answer. Okay. So long story short, we had common precision in the tenths place, and so we have to round accordingly in the tenths place. You're going to have to make a determination whether to round or not. Okay. Here, 5 and up, we rounded, so I have 152.0. Okay. Again, I teach chemistry courses. In a Chem 101 intro course, I would be okay with this answer. This is good. Okay, and maybe we can use it for future calculations. If you want to minimize rounding error down the road, one thing you could do is you could write out something like 151.95, and then you could underline those 4 digits to tell yourself or whoever's reading your work, those are significant, but that one's not. I'm just carrying that around to minimize future rounding error. Another thing I see sometimes is 151.9, and then maybe people will write that 5 like lower as a subscript, and that way they're telling people that I'm just carrying that to minimize rounding errors for future calculations down the road, but it's actually not significant. Or you can just even combine the techniques. Okay. Going forward, for the purposes of this video, I'm not going to be worrying too much about this, and I'm just going to go for rounding the answer to the correct number of sig figs. All right, so I'll just write that out. Correct answer when rounding to correct number of sig figs. Got a few more addition and subtraction examples. All right, to save time, I already wrote most of them out in this neater format. Okay, pause if you want to work on these on yourself. This last one is similar to this one, but I did something a little bit different, especially with that second part. All right. Assuming you had a chance to pause the video and work on these, I'll be using green so that for my answers, so it doesn't look like the problem itself. Okay, so common sig figs here and right there. Okay, 27.9 plus 3865. 3892.9 liters. All right, so to report our final answer, 9 rounds up. So we would write 3.893 liters as our final answer for this problem. All right, let's do the next one. Here we have a subtraction, but the same rules apply. Okay. Oh, I said I was going to use green. Oh, whatever. I'm going to, so I'm going to draw my line here. Okay. Maybe some of you were thinking about a 0, and maybe you were thinking of drawing it there. But remember, any zeros, any trailing zeros that you have in a measurement where a decimal point is present, it is significant. Okay, so that was measured. That's significant. All right. Here's my underlying sig figs to make sure we're on the same page. All right, so we have 54.290 kelvins. Kelvin minus 6.8147 Kelvin. Okay, 47.4753. All right, 4 and below, we don't round up. Some people call that you don't round. Other people say round down. I don't know what to actually call it, but this is what I'm gonna write. I don't round up. Okay, and I get that answer, 47.475 Kelvin. All right, so this next problem, let's see if I trip up anyone. So here we have a bunch of trailing zeros, but there's no decimal point present in either measurement, which means for this first measurement, our sig figs will end there, where that 1 is, and the second measurement only has 1 sig fig, which means our sig figs are going to end in this place. All right. Now, I didn't draw a bunch of commas yet because I didn't want that to clutter the page, but now, after I do this math, I'll put them in. 2, 4, 5, 1, 0, 0, 0, minus 8, 5 zeros. Gonna double check that, yep. And we get 1, 6, 5, 1, 0, 0, 0 milligrams. Okay. So this is going to round up to a 17. 0, 0, 0, 0, 0 milligrams. Now I can worry about commas if I want that. So 1.7 million, in other words, would be our answer. All right. Last problem. Again, I said it'd be similar to this one. Let me go ahead and write it out. So 2451 times 10 to the 6th power and then we have this one. Now I could type 8.00 times 10 to the 5th into my calculator, but then I'll get that. All right, so one thing I want you to take to heart and keep in mind is that calculators, they're not going to think in sig figs. Here I typed in a 3 sig fig value, but it's not thinking in sig figs here. So it's us humans, we have to think in sig figs. Calculators don't think in sig figs. So let me show you what I mean. So this is going to have 1, 2, 3, 4, 5 zeros. Notice how careful I am, how much I take my time in writing out these problems. All right. And there's our problem. So this might present a little bit of trickiness to you. You're like, well, if I multiply this out, I don't have a way of keeping those 3 sig figs in this measurement. You're like 80,000 or 800,000 as written does not allow for me to keep track of those 3 sig figs. Okay. Yeah, that can happen. So the deal with scientific notation is scientific notation is so powerful because it allows you to keep track of sig figs in any situation, whereas something written out as a standard number, you may not be able to write down those sig figs in a proper way. So in other words, scientific notation allows you to write down any measurement, whereas standard numbers don't always allow for that. Okay, I'm not saying don't set it up this way. I'm just saying there's a reason why this problem had to be written that way. Okay, someone actually measured right here. Okay, so the purposes of doing the math, I'm just going to underline those 3 so I know to remember those are sig figs. All right, and then here I'll just underline those. Okay, so those 4 sig figs, those 3 sig figs, and now we have a way of doing this math. All right, I'll just type this into the calculator. So same calculator answer output as last time. That's where a comma is going to go, another comma. But this time, because we had shared precision going down to this thousands place, we can actually write that out as our final answer. So that's the answer. Don't put a period there because that would imply that you suddenly had precision there, and we never did. So that's just a way you would write that. Or you could just keep things in scientific notation depending on what you need to do. All right, cool. That was addition and subtraction. Let's move on to multiplication and division. All right, multiplication and division, we're not looking for a common shared sig fig. Actually, we're just looking for the lowest number of sig figs in our mathematical operation. Okay, so in other words, multiplication, division, lowest number of sig figs in is equal to your number of sig figs out. All right, so my tips, just make sure you count the number of sig figs in each item in your problem, and check your units at the end. All right, now this middle tip is this is where I see the most problems when people are doing sig figs problems. Okay, they'll understand the rules, but then when they type things into the calculator, they forget the part that calculators don't automatically do sig figs. They don't think in sig figs. Sometimes by coincidence, by luck, it'll just have an answer that's the correct number of sig figs, but it wasn't trying to do that. So be careful with the calculator. You have to do sig figs. The calculator doesn't. All right. So what I did with these examples is I chose these examples with, zero. You'll see what happens. Okay, I won't spoil my surprise. So, all right. I snuck in a division here. for its example. All right, so let's count sig figs in each thing. All right, 2.700, that's going to be 4 sig figs. And this second one has 3 sig figs. All right, so even before we do the math, I like to write the number of sig figs in the answer immediately. Okay, we're gonna need a 3 sig fig answer. All right, now this we can do in our head, and we'd get the answer. But let me show you. Let's just pretend we weren't doing this in our head and we were just typing it into the calculator and relying on the calculator. See what happens. 2.700 divided by 1.00. It equals, and it just says 2.7. So here's the temptation. You're going to write 2.7, and you remembered your units. We have grams over milliliters. That's a density value. All right, that was the density of this aluminum block from our previous video. Okay, not this particular block, but this is aluminum. But yeah, as written from the calculator, it only gave a 2 sig fig answer, but we need 3. So it's going to be on you to add a 0 there. Okay, we're not changing the value. We are just simply showing the precision correctly. Okay, so it's on you to add that 0 if the calculator doesn't do that. Okay, so that would be the correct answer there. All right, next up, 2 times 7, we get 14. 14 meters squared. But here's the thing. Oh, I moved a little fast. So let me show you. 1 sig fig, 1 sig fig. That means our answer also has to have 1 sig fig. It's about the lowest number. Okay, above we had 4 divided by 3, so we need a 3, just the lowest number. 1, 1. We need a 1 sig fig answer. Okay, you have to start with the biggest digit you have available. So this has to round down, or not round, whatever you call it. It's going to be 10 meters squared. Okay, that probably doesn't feel great to you, knowing that it should in reality be in the ballpark. It should be about 14, the ballpark of 14, but we were forced to write 10 just due to our lack of good precision in these measurements. All right, so yeah, that's kind of what you're stuck doing. All right, so you say we gotta do better. Let's increase the precision on one of the measurements. So here, 2.0, this is 2 sig figs. And 7 meters, well, that's just still 1 sig fig, which means we still just need a 1 sig fig answer. So that didn't solve anything for us. And we're stuck with that. Same thing here. 1 sig fig, 2 sig figs. The lowest number, so we're going to have a 2 sig fig answer here. Okay. I really don't like writing this. It hurts my heart that this was precise, but that wasn't, and so I'm forced to write something like that. All right, so how about here? This is starting to look a little better. Here we have 2 sig figs. Here we also have 2 sig figs. So finally, we can have a 2 sig fig answer. Oh, I should have wrote a 1 here. Okay, but this problem here will have 2 sig figs. So now I can finally write 14, but I'm not going to write 14.0. Okay. So let me demonstrate in the calculator again. 2.0 times 7.0. It says 14 meters squared. That is all we're going to want. Okay. You might have a temptation. You see a 0.0 over there and a 0.0 over there. The temptation might be to write 14.0 meters squared. But hopefully, you can recognize that this has 3 sig figs, whereas the 2 parts going in had only 2 sig figs each. So we wouldn't be able to write that answer here. Next problem, 3 sig figs. 3 sig figs. We're going to have a 3 sig fig answer. Calculator still says 14, as it has every time. But since we need 3 sig figs, we need to write that 0 to maintain the precision that we had going in. All right, let's do this last problem. So this measurement here has 1, 2, 3, 4, 5, 6, 7, 8 sig figs. Okay, someone measured that perfectly. Oh, I'm missing a unit. I meant for this to be meters. But this measurement here was not done very precisely. So, once again, we would have 1 sig fig in our answer, even if the first one was done very precisely. All right, I hope this helps. If you encounter any examples that you feel weren't fully addressed here, I'd be happy to tackle them in a separate video. Feel free to send them over to me. But again, hope this helps. Thanks and take care.